Okay, just kind of looking through what I hope we learned on the last slide or video. The compound interest is given by A equals P times the quantity 1 plus R over N raised to the N times T power. So the 1 plus R over N is raised to the N times T power and not the P. The P is just a coefficient. So the 1 keeps the money from before compounding. In other words, it keeps whatever your previous amount of money was. The R over N adds interest at each compounding. The N times T is just the number of times the interest is compounded total over time T. N times per time T, per unit time, times the number of unit times. That made sense? So for example, you invest $1,000 at 3.1% annual interest, compounded weekly. So it's annual interest compounded weekly. How much is your investment worth after 7 years? See at the parcel of the word. So the annual interest. So it's the units is years, because annual means per year. Invest 1,000. 1,000 is your principal. Your interest rate is 3.1%. Percent means per 100. Per means divide. So 3.1 over 100 is what that actually says. 3.1% means 3.1 over 100. Okay, so my solution R is actually 0.031 because I had to divide the 3.1 by 100, which moves the decimal 2 places to the left. N is the number of times per year that you're compounding the interest. It's compounded weekly, so there's 52 weeks in a year. It's not 4 times 12. Some people think there's 4 weeks in a month, which is wrong. There's 4 weeks in a lunar month, but we go by solar months, which is like usually 30, 31. The only month with 4 days or 4 weeks for the month is February. Everyone else is longer. So it's 52. It's the same as the number of cards in a poker deck. It's actually 4 times 13. 52 weeks in a year. P, the principal, is the initial investment. That's $1,000. So I'm just writing out what all the variables are that were given. And then they want to know what the investment's worth after 7 years. So T is 7. I don't know why I didn't write that out there, but I didn't. So you get your amount, your future amount, equals 1,000 times the quantity, 1 plus 0.013 over 52, right? Raised to the power of 52 times 7. Notice the 52 comes in twice. In one, you're dividing, making a number small, and in one, you're raising it to a power, making it larger. So they kind of counterbalance each other somewhat. And if you multiply that out, hopefully using a calculator, this is a good use for a calculator, you get $1,242.26. And if you look at it, you kind of look at it for reasonableness, right? That's kind of how you check this. You invested $1,000, 3.1% annual interest, compounded weekly, and you left it in there for 7 years. Does it seem sort of reasonable that you'd have $1,242.26? Sure. It's not like $10 billion, and it's not like $3.18. Like you're earning interest and you end up with less than you started with. You know, you're going to end up with a little bit more than $1,000. 3.1 interest is not very high, so you don't expect a huge amount. But it is 7 years, so you do get $242.26 in interest. So it's something. So what if the interest is compounded daily instead of weekly? And here they just assume you have 365 days per year. They're not going to use like a more accurate one. The text usually just uses 365. So then I would have the same thing, only with 365 replacing the two places where there's an n. So my n is 365. So I have 0.031 divided by 365 for my rate. And then 365 times 7 is the number of compoundings. And when I multiply that out, I get $1,242.33. Compare that with compounding weekly. So I'm compounding 7 times as often because I'm compounding daily as in the previous example. And what am I gaining? I'm gaining, looks like I'm gaining 7 cents over 7 years. It's not a lot. 7 cents more over 7 years. So compounding more often can give you a little bit of extra money, but not usually a whole lot. Okay, so I just wrote that out. Notice you earn slightly more with a larger n. Slightly more.